Alright, so today we're going to be talking about solving 3x3 systems, okay, using elimination. Alright, and this is definitely going to be a little bit more tricky, so just kind of follow along. So what I'm going to do first thing always is I'm going to go ahead and I'm going to number each equation. And now my goal is obviously when we did just two variable systems, which was Monday, it was really easy because we could just cancel one out, and then we would have we could cancel one of the variables out and then have just one left and solve for it. And then we would go ahead and once we solved one of those variables, we would plug back into one of the original equations, right? Okay. Unfortunately, with 3x3, that is difficult because now you've got x, y, and z. So what we're going to do is we're going to use all three of these equations to cancel one, and then we're going to make new equations, and then we're going to use those to cancel for another. We're going to find one of the variables, and then we're going to go back and plug values in to come up with x, y, and z. Okay. All right. So here we go. Right. So I numbered these so that you could kind of see what I was doing here. Right. So I'm going to go ahead and I'm going to use numbers 1 and 2. So let's write those out. So we got x minus y plus z, okay, equals 0. And then we're going to use equation 2 because what I notice here is I see x and negative x. So we're going to go negative x plus 2y minus 3z equals negative 5. Now, usually we need to go ahead and we need to multiply. Okay, we need to go ahead and multiply stuff to be able to cancel something out, but in this case we don't have to. Because look what happens here, x and negative x. So they're gone, and so now I'm left with, let's add these all together. Negative y plus 2y just gives me y. Z plus a negative 3z is negative 2z equals a negative 5, and this is what we're going to call equation 4. Now I was able to cancel the x's out with 1 and 2, but I still have x here with equation 3, so I can take either 1 or 2 and go ahead and cancel the x that way as well. So we're going to go here, we're going to go equations. We'll use 1, which I'm going to go ahead and multiply everything by negative 2. So that's going to be negative 2x minus 2y minus 2z, sorry, positive 2y minus 2z equals 0. Okay? And then I'm going to use equation 3. I'm not going to touch because it's going to already give me a positive 2x here. It's 3y and now look how nice that is for me because can I get rid of the x's now? So what you're doing is you're kind of just taking what we learned with Monday, and we're just instead extending it a little bit, setting it up to where we can get rid of all the x's. So by doing this, look what happens here. Now all the x's are gone. Let's go ahead and add these together. So that gives me a negative y, negative 2z plus 5z, positive 3z, 8 plus 0 is 8. And now we're going to label that equation 5. Now, x's are gone, so now it's become a lot easier. Now this is going to become kind of what we did on Monday. Okay, I'm going to go ahead and I'm going to write equation 5 now under equation 4 there and see what we can do to canceling that. So I've got negative y plus 3z equals 8. Just moved equation 5 under there. And now, normally if I needed to change something here to get rid of one of the variables, well I would, but look how nice this works out. We now got y and negative y. So those are going to go ahead and be canceled out. And now that's going to give me now 3z minus 2z, which is just c. Negative 5 plus 8, 3. And so we found our first variable, z equals 3. So now with z equals 3, I'm going to go back. I'm going to go back to equation 5. And wherever I see a z, I'm plugging in 3 for it. So I'm going to have now negative y plus 3 times 3 equals 8. So then that's going to give you now a negative y plus 9 equals 8. So that gives you negative y equals a negative 1 because I subtracted the 9 to the right side there. And so you're going to get now that y equals 1. So we got z equals 3, we got y equals 1, and now we're going to solve for x. And so to do that, we're going to go back to one of our original equations. I'm going to use equation number 1 because I find that to be the easiest. So we don't know what x is. Minus, what is y equal to? 1. Plus z. So z is equal to 3 equals 0. That's then going to give you now x. Negative 1 plus 3, that's a positive 2. So x plus 2 equals 0. And so you find out then that x equals a negative 2. And there you go. So that was a lot there. Okay, but we were able to solve for a 3 by 3 system using elimination. Okay. All right, let's go ahead here now and let's look at number 2, and then that'll be it. So we're going to label 1, 2, 3. Now this one's going to be a little bit more difficult, okay? I think, again, I'll just take questions. I'm going to use equations 1 and 2, I believe. Okay, and we're trying to get rid of the y's here. Trying to get rid of the y's. So I'm going to go ahead and take equation 1 here. And I'm going to multiply everything by negative 2. And so when I do that, that's going to give me a negative, that's going to give me a positive. And here's the thing, guys, you got to really take your time with these because you can make a mistake, just like I almost made a big mistake there. Well, a small mistake that would have made the problem way more difficult. So that's going to give you a positive 4x because remember, I'm multiplying everything in this first equation here by negative 2. Minus 2y plus 6z equals 0. And then 2 here, we're going to have, let's do equation 3 here. Sorry, we're going to do equation 3 here first. And then that's just going to leave me 5x plus 2y 8z equals 23. I didn't have to change this bottom one at all because look what happens here. Are the y's going to cancel out? They are. So we're going to go ahead and add this all together. So it's going to give me 9x plus 14z equals 23, and we're going to call that equation 4. All right, now I don't have a ton of room here. I'm going to go over here, and we're going to use equation 1. Okay, so and equation 2. So that means I need to multiply this here by 4. So I'm going to get a negative 8x plus 4y. Sorry, I know this is tight here. I'm running out of room. Minus 12z equals 0. And then equation 2, I don't have to touch because it's going to be that negative 4y, and we want the y's to cancel. Again, remember, I already started by canceling the y's here, so when we use the other two equations, you also need to go cancel y. And so then I'm going to get this. I'm going to get now 3x minus 4y plus 10z equals a negative 7. Add those all together, and so that's going to give you this. That's going to give you a negative 5x. Y's are going to cancel out. Negative 12z plus 10z, it's a negative 2z. And then 0 minus 7 is a negative 7. And so that's going to be equation 5. Now this is where this gets tricky here. I'm going to take equation 4. And I think the easiest thing to do here is I'm not going to touch that one because I'm going to get rid of the z's. It looks like I got an easy way to get rid of the z's. So I'm just going to leave it as 9x plus 14z equals 23. But for equation 5, I see that I have a negative 2z. Again, guys, this is just all looking at it, guess and check, just kind of thinking about how to go about it. I'm going to multiply everything there by a 7. Okay? And so, yeah, actually, I don't want to put the parentheses on because I don't want to confuse you guys. So times negative 2. Well, that's fine. You know what I'm doing. You know what I'm doing. I'm explaining it. So we're going to take equation 5. We're going to multiply everything by 7 there. So negative 5 times 7, that's a negative 35x. 5 times the negative, so negative 5 times 7, sorry, Steve and I can get a little confused here. Negative 5 times 7, that's a negative 35x. 7 times the negative 2 is a negative 14z. And then negative 7 times 7 is equal to a negative 49. So when we do that, the z's cancel out, and now that leaves me with what? A negative 20, negative 26. X equals negative 49 plus 23 is going to be a negative 26. And so we can go ahead now and solve for x. So that means then x is equal to a positive 1, because when you divide the negative 26 by negative 26, you get 1. Okay? So now we got that. So now we're going to go back over here and use one of our equations, 4 or 5. From where we originally found, I'm going to use equation 5 up here. And wherever there's an x, I'm going to plug in a 1 for it, so I get negative 5. Got negative 5 times 1 minus 2z equals a negative 7. So that gives me a negative 5 minus 2z equals a negative 7. I'm going to go ahead and add the 5. And so that's going to give me now 2z equals a negative 2. And so we find out then that z also equals 1. So now that I've found x and z, I got to go back to my original problem. I think I'm going to use equation 1 again. Just seems to be nice here. And so wherever I see an x, I'm plugging in a 1, and wherever I see a z, I'm plugging in a 1. So I'm going to get negative 2 times 1 plus y minus 3 times 1 equals 0. That gives you negative 2 plus y minus 3 equals 0. That then gives you y minus 5 equals 0. And so therefore, move that 5 over to the right side, you get y equals 5. And there you go. So to recap, just a lot going on here, okay? You're going to take 2 out of the 3 equations. You're going to get rid of one of the variables there. You're then going to take the other equation that you did not use from the first here and pair it up with one of the other equations you used at the beginning here, and you're going to get rid of the same variable. By doing that, that means we've gotten rid of all the x's to make it now where we got 2 new equations, 4 and 5, where we just have 2 variables. We then do what we did on Monday, elimination, to get one of the variables by itself. Once you do that, you solve for one of the variables, you go back and plug in whatever you solve for that one variable in 4 or 5 to solve for another variable. And then once you get 2 out of 3, it's real easy. You just take one of your original equations, you plug 2 out of the 3 variables in, you solve for the unknown. There you go. Okay? So yeah, that is a little heavy. Make sure you really take your time going over that today. And yeah, that is it. And I will talk to you guys in class tomorrow. We'll go over it. All right? Thanks.